Thank you for watching this video. Remember, the best way to study is to take practice tests, and if you can't find good practice tests, build your own and learn while you do it using the Learn My Test study tool. It's absolutely free at learnmytest.com, and you can click on the link in our description to take a practice test that I created using Learn My Test. So thank you again for watching. Today we're going to talk about the different structures in the brain. So I do want to show you this picture just to show you that there are two sides of the brain, or hemispheres of the brain. And this is the right hemisphere, this is the left hemisphere. And in a lot of cases, the right hemisphere controls the left side of the body, and the left hemisphere controls the right side of the body. So a lot of times when people have strokes, on the right side, they may be paralyzed on the left side of their body, or if they have a stroke on their left side, they may be paralyzed on the right side of their body. So that's just an example of this term called contralateral. So contralateral means that this side of the brain affects the opposite side of the body. So another thing about the two different hemispheres is that I want you to know is this structure called the corpus callosum, which is right here. And the corpus callosum is essentially this bridge that connects the left and right hemispheres. And it's important because it does connect the left and right hemispheres, but also it's important because people did lobotomies by taking out the corpus callosum in people that have really bad epileptic seizures. And so they would cut out the corpus callosum, and they still do that procedure today. And the reason they came up with the idea, hey, let's cut the corpus callosum, is because they noticed with epileptic seizures that there was electrical activity that was going from one side of the brain to the other. And that's how the seizures were occurring. So they thought, oh, if we clip this, then that would, stop the seizures. And it does stop the seizures, but it can also cause severe cognitive impairment. It can cause visual processing issues. So our brain takes information from both eyes and blends it together to make one whole perception of vision. And when you cut the corpus callosum, it can drastically mess up how you see things. So I'm going to go ahead, and that's a great transition to the occipital lobe. So the occipital lobe is at the back of the brain. So this is the front of the brain, this is the back, and this is the area where vision is processed. And so one of the ways that we assess for damage to the occipital lobe is we ask anybody if they've had a stroke or whatever, we give them a symbol and we ask them to draw it. And sometimes if they have damage to this area of the brain, they'll draw it rotated. It'll just look kind of distorted. They may miss details. And let me show you another interesting test that neuropsychologists give is the clock. And so this is kind of a stereotypical version of a clock that is drawn by someone who has a visual processing impairment. See, they drew the clock, but it's all on one side. They completely missed the other side of the clock. All right, so that is the occipital lobe. It's responsible for vision. So this is the parietal lobe. So the parietal lobe is responsible for sensory processing. So basically touch is a really big important thing as far as the parietal lobe. And I'll jump into that in a second. And then obviously, like I told you before, the contralateral. So this is kind of cool. This is called the homunculus. And so this is the parietal lobe right here, and then this is the frontal lobe. So the parietal lobe here there's a spot on this in this area this area is called the somatosensory cortex. So this is called the somatosensory cortex, and it's where all it's basically where all the sensations are processed in the brain. So if you get burned, if you get burned on your hand, it will get processed up here. If you get burned on your face, it will get processed up here. And they created this character, so they've actually mapped out the somatosensory cortex to basically how much space each body part takes up. And so they created this this figure called the homunculus, which is basically it's everyone's body size relative to how much space it takes up on the somatosensory cortex. So you can see that you have a, the hand, there's a lot of space for your hands, a lot of space for your lips, not as much for in here. So you don't have as many sensory touch receptors in here, mostly on your hands and your face and your ears, which does make sense, right? So when I say the parietal lobe, I want you to think of the somatosensory cortex because that is the most important part of the parietal lobe. So let's jump forward. So now I have the frontal lobes, which the frontal lobes are, basically getting stuff done, like attention, planning, concentration, learning, impulse control, judging risks and rewards. And another important is speech production. And let me go into more detail. So this is the somatosensory cortex, or sorry, this is the motor cortex here. This is the somatosensory cortex, or sorry, this is the somatosensory cortex right here. And so it's the line between the parietal and frontal lobe. So the somatosensory cortex is here, and the motor cortex is right here. So this is the part of your brain that basically tells your body parts to move. So this is conscious movement. So if you want your leg to move, your arm to move, this is where your brain sends those signals down to your body to tell those things to move, right? So let's moving forward. Another important part of your frontal lobe is this area here, and it's called Broca's area. And Broca's area is responsible for speech production. So if you have damage to Broca's area, you won't be able to speak. You may be able to understand what people are telling you, but you're not able to communicate through spoken language. So that is, and when that does happen, when you have damage to Broca's area, it's actually called aphasia or Broca's aphasia, or it can be called as conduction or expressive aphasia. So when you have damage to any part of the language centers of your brain, it's called aphasia. And one of the ways that we neuropsychologists assess for aphasia is we will ask you, or for expressive aphasia, is we will ask you to name as many words as you can in 1 minute that start with a certain letter. And so people with damage to Broca's area, they have trouble doing this task. So this is Broca's area right here. So remember the motor cortex is up here, somatosensory cortex, parietal lobe here, occipital lobe is back here, and then this is Broca's area responsible for speech production. So another cool area of the frontal lobe is this is the risk reward pathway. So it goes through through the prefrontal cortex all the way up here. And what this is it's basically your ability to judge the risks and rewards of certain behaviors. So like gambling and things like that. And one of the cool things just to think about is that research has said that this pathway is actually not fully developed until you're about 25 or 30 years old. And this is why adolescents actually take more risks than middle-aged and older adults, because their risk reward pathway is not fully developed, so they may make a lot of poorer decisions than their older peers. So that's just an interesting concept, and obviously, this has been used to try to get some legislation around, forgiving certain people who have been arrested and things like that, especially because people do generally become better decision makers as they get older. So just a side note there. So the temporal lobe is down here, and I like that it's called the temporal lobe because it's kind of right by your temples. And one of the biggest, most important things about your temporal lobe is it processes auditory stimuli or hearing, and an oversupply of dopamine. I know we talked about this last week, but an oversupply of dopamine in this area, the temporal lobes, is related to delusions, or not delusions, but hallucinations and schizophrenia. And speech comprehension is also in the temporal lobe. So your ability to understand speech is in the temporal lobe, and this is called Wernicke's area or Wernicke's area, and it is the area for understanding speech. So if you have damage to this area here, you may be able to talk, but if as long as Brokaw's area is not damaged, you might be able to talk, but nothing that you say will make sense. So that's called receptive aphasia or Wernicke's aphasia, if that happens. All right. So this is Wernicke's area. This is responsible for speech comprehension. So a couple structures I want you to know. So this is the brain stem. And then this little bowl of spaghetti in the back is the cerebellum, and I'll talk about the cerebellum in a minute. But this is the medulla oblongata. This is the pons. The medulla oblongata is responsible for breathing, heart rate, cardiovascular functioning. So it's basically the way that your brain communicates with your heart. And then the pons up here is responsible for sleep consciousness, bladder control, and then all your sensory information runs through the pons. So if you have damage to the pons, you'll be in a coma. So this is the cerebellum. So the cerebellum is the area in the back of the brain right here, and I'll just jump back to this slide. So this is the cerebellum here, and then in this slide, this is an actual MRI of a cerebellum. And cerebellum is associated with balance, coordinating, learning, and muscle memory. So those types of things like overlearned tasks are processed in the cerebellum. And cerebellum is a structure of agility. I'm going to quote Dr. White, Dr. Leonard White. I took his functional neuroanatomy course on Coursera from Duke University, and he described the cerebellum as a structure of agility, meaning that it makes you do everything better, especially when it comes to movement. And so one of the interesting things, and the reason I'm showing you this picture, is that alcohol actually impairs the cerebellum, or it actually reduces activity in the cerebellum. And so that explains why when you drink alcohol, you have trouble maintaining your balance. You might fall over easier. You may have trouble paying attention and focusing. And in some cases, you drink too much, you may black out. But continued excessive alcohol use over time can lead to degradation or a decline of the cerebellum. And you can see here, this is the cerebellum of an alcoholic. You can see it's missing, a lot of it's missing right here, whereas this is a cerebellum of a healthy adult. So alcohol can definitely has negative effects on your cerebellum. So this is the thalamus. The one thing I want you to know about the thalamus is it's a relay station for all sensory information except the sense of smell. So everything, vision, touch, taste, all the stimuli, or all the different senses except for smell, run through this structure called the hypothalamus. So if you, or not the hypothalamus, the thalamus. So if you have damage to this, you will lose all your senses except smell for a while at least. So this is the hypothalamus, and the hypothalamus is responsible for regulating hunger, thirst, temperature, sex, those types of things. And there's a couple other, there's a big important part on the hypothalamus. This is called the suprachiasmatic nucleus. And the suprachiasmatic nucleus is an important structure in terms of regulating sleep. So that's in the hypothalamus. So the hypothalamus is also related to sleep. And I know we talked about in the last video on the endocrine system. And so I just wanted to show you, this is the pineal gland right here, the gland that secretes melatonin, that helps you sleep and helps you establish your sleep schedule, right? So the hippocampus, so this is what a hippocampus looks like, and this is where it's located in the brain. The hippocampus is an extremely, extremely important structure because it's responsible for memory, and it's basically working memory is the hippocampus. And so the hippocampus is believed to be the first thing that's damaged in Alzheimer's disease, which we talked about last week as a neurodegenerative disorder that is associated with these fatty plaques building up that shut down certain areas of the brain. So the hippocampus is believed to be the first structure that's negatively affected by these plaques in Alzheimer's disease. So the first thing that happens with people with Alzheimer's disease is their memory tends to be the first thing that's affected. But so when I say hippocampus, I want you to think of memory, because your hippocampus is the memory center of your brain. So this structure right here is called the amygdala. It's a little walnut structure, and the amygdala is extremely important in processing emotions, mainly negative emotions like anger and fear. So another thing I want you to know, the final thing, is called neuroplasticity. Neuroplasticity is your brain's ability to reorganize its functions to different areas of the brain when one area is damaged. I've worked in a rehab hospital before where we see people that have had strokes or some kind of brain injury. And one of the things that we'll tell them is we'll say, you know, you've had a stroke, this area of the brain has been damaged. And so now your brain, now there's a big pothole because this area has been damaged. And now your brain has to find new ways to do the same things. So a lot of times when people have damage to certain areas of the brain, like Broca's or Wernicke's area, for example, they have to learn how to talk again. And those areas of the brain that they used to use for talk, they can't, to talk and communicate, they can't use anymore. So their brain has to find a different pathway. And there's so many neurons in your brain that your brain actually can a lot of times find a different pathway or a different way to do something when it gets damaged. And your brain is actually a lot more resilient when you're younger. So when you get older, your brain becomes less plastic, which means it's less able to do that. But it's still able to do that, just not as well as when you were younger. So I want you to watch the video on Ben. It's called The Boy Who Sees Without Eyes, and it's about a boy who actually is able to process auditory information in his occipital lobe. So he's actually able to see with his ears, with audition. So it's very interesting, very interesting story and video. So I would definitely encourage you to watch that. Thank you so much for watching this video. Remember, the best way to study is to take practice tests. If you like the video, please hit the like button and hit the subscribe button to stay up to date on our most recent videos. Thank you again for watching.